Okay, so we're gonna tell you a couple property that's in integrals and why that's relevant. So first property is pretty intuitive. What's integration between a to a of f of x dx? What do you think that's equal to? That's a first property. But you don't need to understand property to understand this.
Are we saying that A is the same number?
Yep.
Is it just zero?
That would be just 0. A lot of people think that's intuitive. It is intuitive. Because you think about it. From area from 2 to 2, do you have any area?
No.
You have a straight line, right? Straight line is one dimensional. It's no area. It's a very, very, very thin line that has no area on it. Could be infinitesimally small. Okay, so that's the first one. The second one is I will tell you. So this is easy property. This I don't need to teach you. You already fundamentally understands it. The second one's kind of tricky though. I'm going to tell you in a second. If you have area between a to b of f of x, right, between a to b, and that could be any random number. Okay, it could be any random number. Now, if I decide to switch the boundaries, so let's just say if I switch this boundary between a to b, I switch them. If I switch them, they don't equal each other, but they are equal to negative of that. So they equal to negative of that. So if I ever switch the boundary, I have to insert a negative sign in the front. So if I switch the boundary, you need to put negative sign in the front. Okay, you put a negative sign in the front.
Yeah, I was gonna ask, how do you have like a negative area?
Okay, so that's a good question. The area always positive, okay, but the integral can be negative. What I mean is this. So let me stress something first before I talk about that. For Mr. Ye's teaching all this year have all this experience of failure, more than anyone you know, is I suck at everything I do. So I fail a lot. But throughout those failure, I learned a lot of things. I learned just told student keeping in one perspective, it will make things a lot easier to try to overcomplicate things. So what I will tell you is I will prefer always the number here is always less than the upper bound. So lower bound is always less. So I will say more negative here. I would prefer the setting always. I prefer this is more negative and this is a more positive. What I mean, if I have 3 and 2, I will put 2 on the bottom and 3 on the top. If I have 5 and negative 2, guess what? Negative 2 is going to be on the bottom, 5 is going to be on the top. I prefer this orientation. If this orientation, all you got to do is consider are they above or underneath. So now let's come to, its area cannot be negative. No, area is positive, but the integral can be negative. So that's the part that's really confusing about. So let's just say if I have a graph like this, right? If I have a graph like this, let's just say if I have a graph like this, okay? So integration between 0 to 3 of f of x, well, we know this is above x-axis, right? This is above x-axis. So therefore, this one is 3 times 3 over 2, which is 9 over 2. Does that make sense? Now, if I went to negative 3 to 0 of f of x, well, area is a positive, but since they are below the x-axis, in order to make sense, this one has to be negative 9 over 2 because it was the area on the bottom. So that's why it's negative. So if I shade it, I will shade it as a different color like this. It was negative because it's below x-axis. Does that make sense? But I always keep the lower number on the bottom, like negative 3 to 0. I won't do 0 to negative 3. The test question, however, will give you a trick. Ask you to play with it. Okay. So here's my question to you. And pay attention how the question is worded. Before that, I need to talk about one more property. So first property is this one. The second property is this one. And third thing is make sure the lower bound, it's just, I always prefer more negative. I preferred it. It's not because textbook preferred it. I preferred it because I know students always struggle with this kind of situation. So I always keep the bottom as low. So all you gotta do is know if they are above x-axis or below x-axis, you know your sign. Okay? Now one more property is this. If you have C between A and B. That's the first situation. Okay, so I have some type A functions. And we have A. We have a B. And C is right in between. Okay. So this area from here to here. And this area from here to here. So what does that mean? That means integration between A to B of f of x, you see that lower bound is on the bottom, is equal to integration from A to C of f of x dx plus integration from C to B of f of x dx. Does that make sense? It's just two pieces. It's called additional property of two area you can add together is equal to the big area because C is right in between. It's very, very intuitive. And the best thing is you can suck at calculus. This kind of question is plenty. You can actually do it. You don't have to be good at calculus to understand this type of stuff. It's like a very logical thing. You just have to make sense of it. You don't need to know how to do algebra either. Maybe a little bit of intuitive thinking, yes. Okay, so I'm going to give you a question. I want you to guys debate about it. This question is going to look like this. I will have 2 times. Can you give me 2 numbers that you like?
7.
Okay, let's just say 1 and 7 of f of x. It's equal to negative 10. And I say, hey, between 7 to 4 of f of x dx is equal to, give me a number. 5, okay. That's fair. What is integration between 4 to 1 of f of x dx? Remember, you're changing bounds. Remember also the low bound on the bottom. Those are the things that you gotta think about.
Because you flip the 7 to the bottom. So it's going to be equal to the negative 10, right? Because of the second property. So they went from B on top to B on the bottom.
Well, they're all different.
Oh, so 2 though.
4, 7, and then 1, 4.
We're solving for integration between 4 to 1 of f of x dx.
4 to 1.
I don't like this number. Can I change one of the numbers? I'm gonna change this to like 2. I think that'll be a better way to not get confused.
Seven, 1, and 4, 7. 33. Define 1 to 4.
Okay, so I'm gonna go through it really quickly. So integration between 1 to 7 of f of x is equal to what? -5. Does that make sense? So that's the first thing. So second thing is between 1 to 7 of f of x dx is equal to what? Is equal to from 1 to 4 of f of x dx plus from 4 to 7 of f of x dx. So now this one means integration between 4 to 7 of f of x, if I flip them, is equal to -2. Does that make sense? So that's equal to -2. And that's equal to -5 between 1 to 4 of f of x dx. So between 1 to 4 of f of x dx is equal to what? -3. But they didn't ask from 1 to 4, they asked from 4 to 1. So therefore my answer is what? 4 to 1 of f of x dx is equal to 3. Does that make sense?
And you get -5.
So do you see that's 2 here? And I want to find out one integral.
You divide them?
Huh?
You divide?
You divide both sides by 2.
Have a good day, Mr. Young.
You too. Hey.
You know what? My mom sent me something and told me to show you because I told her that you would want to go to the
Oh, okay.
canyons.
Cool. Hold on. You guys have a drone?
Yeah,
Nice.
it was so pretty. I saw this and I was like, it's so pretty.
She said she did this?
Yeah.
You didn't know you had this picture?
Well, she was editing it. I knew that we were making it, but then she made like a whole movie out of it.
Oh, wow.
Yeah, it was humongous. That's us.
She's really good at editing, though. Yeah, you really need a drone to see the whole
Okay,
aspect.
so it's not quite legal.
Huh?
It's not legal to use a drone there, and we didn't know until we went to the Grand Canyon because we were trying to do it there, and someone was like, "It's illegal. It's a national park."
Oh, okay.
But whatever.
Yeah, when you don't know, then that's not being illegal. Yeah, that's really, really, really pretty.
Were we doing the test today?
No, we not have a test.
Today.
I thought it was that.
No. Test on
Said
Wednesday?
either Friday or Tuesday.
Well, that's probably because I'm dumb.
Why is Ohio State that color? That doesn't make sense.
What about Ohio State?
Your sweater says Ohio State, but it's the
Yeah,
wrong
that's
color.
from Ohio.
Huh?
My dad's from Ohio.
But it's not a white color, right? Ohio State jacket will be
It's
like,
red and like white or gray.
they don't have blue though.
They're not blue, but this is like navy blue. It's almost black.
Yeah, but their color's red, right?
Yeah.
That doesn't make sense.
Mr.
Yeah.
Chief, I have a question. So in our summation equation, the I starts from 1 or is zero?
It starts from 1.
But what if it starts from 0?
Then you're gonna have some type of shift. You're gonna have some type of shift
So
of,
do we have to add something?
I don't think we have 1 for 0, do we?
Yeah.
They all have 1.
In the trigonometry.
In what?
In the trigonometry one starts from 0.
Are you sure?
13.
13.
Student, 1 minute remaining until class.
It says the first one is cosine 0 plus cosine of 2 pi over n. Would that mean that n is 0 then?
Because I was doing them and I just
Or would that mean that x is 0?
did the expression and I'm like, no.
I don't know, I need to look at it.
I heard you called me funny.
You're pretty funny.
Oh, like the weird ones? Yeah, I don't. I was just thinking of like one.
Why?
Because you went over all the, like, how to put it in integral form, and then we went over one question about the actual expanded summation, and then the rest of the homework was on that one question.
This one. You never answered
The expanded stuff, I didn't understand, like, exactly, I didn't understand, because we only did one question, and I was confused.
Yeah, but it's a very intuitive.
No, I know it is, but I forgot, like, because we only did one question, I forgot what the intuitive process was, and I blanked. And I forgot, like, what do you do with, like, there's no A, I don't know math. Like, this is how action, I didn't know there's no A.
It's a common sense.
Zero.
Wow.
A was 0.
Yeah, no, I didn't understand the intuitive process, because we only did one example question.
That's good.
Jonathan, can you help out Connor? He's not too smart.
Yeah, you know.
I actually did the homework.
He knows too.
I got a print.
He has his moments though. Like,
He has his moments.
See, like, if I have an answer, what I did last year though with Cooper is he would have an answer key for the homework, so I would reverse engineer the problem. And figure it
I
out.
know, I know.
What I did with Craig was I was online the first half, so I just played Xbox. The second half he let you use your phone in classroom, so I just played Clash Royale.
Yeah, that's literally what I did all year.
And then I got it through on the exam. I didn't even know how to take a derivative. To be honest with you.
You don't need to know how to take a derivative to get a 3 actually. Like I can get away with a whole test without knowing how to take a derivative.
I'm just kind of bothered, you know.
Yeah.
All right, so but I don't want you to get a 3 though, Bobby. I want you to get a 5.
I'm gonna get a 5. I'm gonna get a 5 this year. I'm gonna get a 5 this year.
Okay, yeah, please.
Why do they call it power rules in the group? I don't know. We should erase
Are they only learning power rules now?
No, the power rule is on the top. The x to the n.
Wait, then why do they have them all up there?
Yeah, it's right on. Should be right on the top. But anyway, you probably think about power series. We're gonna do that later. So those of you guys are interested for math competitions is at January 29 in Orlando Science. I do want you guys to participate. Just because I think all you guys did horrible on that test, but it's actually a good thing to go because you learn more from a failure than you learn from success. So I do want to see if you guys willing to participate. It's especially so close because OSS is like literally is 5 miles away. So, and I know I've been talking to Luca before, about forming a team. So we definitely need a team for calculus. We can form 2 teams. One is Calc 1 team and Calc 2 team. So I definitely need like 4 members at least from this group. So
We got this.
We got a 4-man team
We're
already.
gonna form it right here.
I think you got a 3-man
Nicole's
team.
gonna carry us, and we're just there for
I
moral
think you
support.
have a 3-man team and a hostage.
That is more accurate.
No, I mean there was individual part of the test, and there is a group part of the test. Yeah, but I'm gonna select the team member. I think honestly, if you 3 in a team, you're annoying everybody in the competition.
Exactly. We would annoy everybody so much that they quit and we
It's
win.
over.
He'll be like, "Shut up."
Exactly.
I have a feeling like they will ban me forever.
They can't ban you.
Okay,
They can't ban you, they can only ban us.
Does everybody like take the test in the same room?
Yeah.
Okay, so if we keep shouting gay jokes, they'll eventually get annoyed and distracted. And then Nicole does the work on the side.
Exactly. Because she's used to working through the gay jokes.
Okay, I only want you guys to individual. I don't want you guys to do the group. Group right now, I already talked to, I know Eva talked to me before. I don't know if she still want to do it. I know Nisha, I talked to her. I don't know if she still want to do it. I know Luca for sure. And I talked to Margarita. But more welcome anybody to join. But individual for sure. Individual is 30 questions in an hour. And those 30 questions is harder than AP exam. So the reason why I want you to do it is because it's actually good training for AP exam. And they are harder. They are much more harsh. So if you can see that and you go back to an easier test, you're going to be like, oh yeah, this is a cake. Rather than, oh shit, I don't know how to do anything. So I like to push people to the harsher environment. And when they go to easier environment, you're going to be like, oh yeah, this is way easier. They probably have another one in Seminole High School, which is probably 30 minutes away. I don't know if they have one this year, but they probably have one. So I will probably think about going. But if you are thinking about going, you let me know. I'm not going to force you, but I might give you some incentive to go. Because that's going to be something it's actually pretty cool. It's a very, very nerdy competition, yes. All the people are like Asian, Indians,
Yep.
and wearing Mu Alpha Data shirts, but imagine that you guys can do fairly good job, maybe. Just don't get negative point. Whatever you do, just don't get negative point. You can get negative point, by the way. If you guess all the questions, then you get negative point if you get them all wrong. So
Just get one question.
Wait, so it counts? It's not like the SAT where you get points for guessing. It's
no, it count against you if you guess wrong.
So if you don't know it, don't put an answer.
Yes.
That's
If
like-
you don't know it, you don't put an answer.
Yeah, that's about to be completely blank.
The only answer is what's
Can't go
the
negative.
Yeah, then if you don't get negative, you're not gonna be the last.
So if I just,
Because somebody is gonna take it become negative.
if I just leave it like default, I won't.
Well, I just told you how hard the test is. I have a girl named Suha. She got -2 on one of the competition. She got into Vanderbilt for a ride, so. And she got a 5 on AP
How do you
exam.
expect us to be able to take it?
Huh?
How do you expect us to be able to take it? Or me in particular?
I think you would do better than you
Maybe
think.
someone in here.
I think you do better than
A
you
lot
think.
of the questions were like logic questions and not like
Yeah.
Be going crazy.
I do want to bring the most ratchet group there.
Oh,
So
no,
add me
I'm
to it.
going
Add me
go.
to it.
Let's go.
I need
Yeah,
to be
we're
there
ready.
if you want a ratchet group.
We'll walk in yelling and stuff. Yeah, we got this.
Most annoying one.
Yeah.
Yep.
They'll be like, who's the coach? I'll be like,
Me, Bobby, and Connor will all be holding each other's hands.
Exactly. Oh, you guys want to like hold hands? and
Start
say-
speaking
Only
like, start speaking like
you wanna
Mandarin,
put
they
your
won't
hands in
know.
each other's back pockets.
We just pretend like we don't understand English.
No, I'm telling you, that's what he does. If he has embarrassing, he can start speaking Mandarin. No.
That's true. He can teach us Mandarin. Just kidding. He teach us Mandarin.
Sure.
We can beat them all with our Mandarin.
All right, so let's talk about math. Let's talk about math. Questions.
Questions.
Like all of them. Like how do we do the summation thing?
No, wait, no,
Like how do we do?
I had questions, and then Logan just told me that it was kind of dumb. It's just zero. Like for the
Yeah, like if there's no A, then
It's zero.
and
Yeah, I
B
didn't put
minus
that,
A is 1,
I didn't put that together.
then 1 minus 0 is 1.
Yeah, I didn't put that together. So that it could be zero.
I closed it.
I gave it like 2 seconds and I was like, Nicole, how do I do this? Like, she gave me one question. I was like, oh, it doesn't matter.
That's the whole thing.
All right, so
I did not do 13. I was very confused by that one.
Dude, I didn't do most of them because I didn't know how to do the summation shit.
I can help you. Maybe you need to change something.
I felt easier than
I'll give it to you later. Yeah. Okay.
Okay, so it's good. Oh, you want to see something crazy? Oh my god, last time was good.
okay, so this homework either is really easy or it's very very hard to understand, but it should be very easy. So the first part is we already talked about the first part. The first part is just like this.
Can you blow that up?
I didn't write for the first.
Is there a way to zoom, or do we have to use like our spidey senses to see that?
The first one is 2 to 5.
Get a glasses.
Can you not read that, Connor? Are you blind?
Connor, do you need your eyes checked?
You cannot see. I can see.
Yeah, you're
I can
sitting
see
a bit
it. I don't know what
closer.
Connor's
Well, I mean,
talking
you have
about.
glasses on, so.
Yeah, and you're way closer, but I can still see it. So Connor should be.
Well, no, we did 1 through 3.
Yeah, 1 through 3 we did.
Okay, so this one's okay, right?
We did 1 to 4 actually.
Oh,
That's a lot smaller.
Okay, yeah, that made it worse.
All right, fine.
Replace with X.
Is that better?
So function is 1 over X. Okay.
Wait, how did you even write
Wait.
Oh, I'm so
Did we
good
say
at
1
math.
was A on that one?
Dude, we did that in class.
Oh wait, crap, I'm not good at math.
No, we didn't. He didn't explain it.
How is number?
No, I
No,
got
that's number 4. I was thinking
I did the
number
bounds
five.
wrong. How did I do that?
Number 4 I got 1 to 2.
You can close it.
Number 4.
Yes. I can't do.
So wait, where's the I in this situation? We just have to make the I like
Okay,
appear out of our
what's
ashes
number 5?
when we're doing that.
I decide.
So we just make it appear
Yeah.
from the summation. Okay.
The summation is
I is
what
what
does the 1
incrementing.
over n and then goes through.
Yeah, Logan is right. I is the increment of 1, 2, 3, 4, 5, and they are in orders.
Yeah, I just there.
So I is what changes the numerator in the bottom fraction.
So facts.
No cap.
So over
Big
time,
facts,
I-
fat facts, no capital topic.
No kidding.
Does that make sense? Okay.
Yeah.
I'll see a different one.
Another basic mistake. Okay.
Yes,
So,
okay.
hold on, pause. Which question?
Okay, yeah, so it's
Oh,
0.
This is the one I didn't get because
Yeah,
I don't understand
it's
A can equal 0.
It can be 0.
Yeah, no, I just pulled that out.
Okay, so that's,
Logan's a genius.
and you're putting it in
No,
what?
again, it was Nicole.
That's Nicole.
I messaged Nicole at like 8:30 and I was like, hey, how do you do number 5?
How do you do that?
So it's F, you always write F.
It's like, just count, guys. Start from 1. Start from 0.
So it was
So it's literally,
1 X.
wait, where did you get the X squared?
Do you see all the
Oh, I
things
see
as
the
square?
I see the square root.
It's square.
But it's 1 over n, you know?
I have a question. Why is like the last part n minus 1 over
That was
n?
all
Yeah.
calc already?
That's how you're getting the number.
Like, it's in calc.
Because that's the. It starts at 0, so your last number is it starts at 0. That means it's actually using. Hold on a second. It starts at 0, and so it's a this is right end point. So right endpoint is gonna be n minus 1 because you don't want it to be over. Because you have a you plug in whatever number in there. Hold on a second, let me think about it.
So, since it's like n minus 1, and it starts at 0, would 1 over n be like the third term in the sequence?
1 over n is the first term. 2 over n, 3 over n, 4 over n. And let's just say it's 5 minus 1, so...
But if n is in the denominator of a fraction, then why is it x squared, not 1 over x squared? Riddle me that.
Wait, what do you mean?
Batman. Wait, what's the
What was
question?
your question?
Why is it not 1 over, like, why is it not 1 over x squared?
Because that's delta x, and delta x is part of that.
Delta x
F
is
of
1
x
over
is
n.
equal
So
to a plus
x
delta
is
x
1 over
times
n.
I.
Yeah, because it's on the outside.
Yeah, so in this instance, a plus delta x plus times I is just 1 over n, because a is 0, delta
So
x.
how did we get from number 4? We got 1 over x.
Because this one, the fraction is the a plus delta x is at the bottom of the fraction.
It's
Uh,
1 plus
So
1
it's
plus.
in the fraction instead of.
Okay, so it's gotta be like a
fraction,
double
yeah.
fraction type situation.
Yeah.
Exactly.
That's pretty wild. Wait, number 5. Okay, so then yeah.
Actually, I don't know why it's n minus 1 over n.
Mr. Yeah, I'm slowly starting to process what's happening right now.
Wait, you just say?
I actually don't know why it's n plus 1 over n.
Which one?
Are you saying what?
Which question?
N plus what? What are we talking about? Are you talking why like the n thing is n minus 1?
Yeah,
I disagree.
Yeah, I also don't understand.
I assume
I'm a genius.
I looked at it and I was like, I have no clue, so I just went with the rest of
the
it.
ending one was very confusing.
Yeah, I just assumed, I just changed that.
I think, I think in this question they use a left n approximation rather than right n, and that's why you have an n minus 1. So if you have left n, you're gonna start at the most left situations. So yeah, I think that I believe is because that is a left n approximations. But it doesn't matter if a left n or right n approximation, you break to infinite pieces, you're still gonna get exactly area under the curve. So you break to you cut it to infinite amount of pieces. So I think this is a left n approximations.
And it's the infinite amount of pieces because n is approaching infinity?
Yep.
Okay.
Because you basically, just like what I did with Desmo before, the original like maybe 10 slices, and I can break to 100 slices, 1,000 slices, a million slices, and that's how you get exactly area for the integrals. Because you have this limits. So that's why calculus, you need limits. Otherwise, calculus, it doesn't make sense. But yeah. So here's the answer for other ones.
Oh my god, 6 was exact. Okay, Mr. Yeah. See, I just needed a little tweak in my brain, you know.
Oh, it's sine pi left.
Yeah, so people miss the pi because I think Margaret showed me yesterday in the single pi.
Did you solve most of it?
No, but I can solve that definitely.
Oh, you actually solved the definite integral and got to a direct answer.
No, I'm looking at it right now, I can solve that definite integral.
Oh, really? You can solve the definite integral right now. What is it?
Is it up 0 to 1 of x?
Yeah.
It's gonna, hold on, let me do my quick calculations.
Dude, how do you not know this?
It's
It
gonna
should
be
be a snap. It
1/2.
should be a snap. No. Yes. Yes.
You just said no.
I said
just
yes
no.
though. Well, you confused me because you took too long and my brain
I
got
was
bored.
messing with you.
My brain got bored.
Why did it take you that long, bud?
It felt easy to do. At some point I was like.
What about if that was a 2 at the top?
If there was a 2 at the top, that would be 1.
Okay, question about this.
0 to 2 of x.
Good?
0 to 2.
Could be 2.
Liam,
No,
good?
1.
X squared over 2.
Are you stupid?
And who's
Okay, guys, knock it off. Jesus. Sometimes it's like,
What are you talking about?
maturity is like 3-year-old.
No, 5-year-old. Big difference.
0 to 2 of x is 1. Just think about the.
Oh.
graph. It's a straight diagonal line, 45 degree angle. It's good too. You were right triangle. You're now 2 by 2,
10. Oh wait, what was 9?
and it's split in half. You don't have to do antiderivative.
No, it's still be two.
Nice right here.
The answer is 4x.
0 to 2 on x.
11 was 3, 6.
Luke said I'm not three.
Because not another graph of
It's
1 to x.
13th one. The I starts from 0.
So wait, all of these problems are exactly the same, Mr. Dave? Like they're all just the same thing. Like there's no tricks, there's no trying to screw with you.
What'd you just put?
Well, there are one answer that you can have two answers here. At number 14, you can have two answers. So it basically is because there's a shift. You can have a shift in exactly the same area. So you can have a slight shift depending on what you want to do. You can use a right-hand approximation or left-hand approximation. That really depends on here. So you have a shift, it's going to give you the exact same area.
Well, yeah. What is going on for that? 2. If you 2 to 3, but why is it? Why are there 2 different answers?
Because you can have a shift, and they can give you exactly the same answer.
Oh, you're just adding you're shoving the 2 down there. Okay.
Do you have to do both, or can you only have? Can you just
You can. You only need one. You don't need both. It's to show you what happened.
Wait, could you stand 14 for a second?
No, that's fine. The dots are right.
14. I got it.
Yep.
The 13th one, the I starts from 0.
No, I actually understand now.
For which one? 13.
I got it. 0 to 1, right?
It did start at 0, but the same situation. This is the left hand approximation, not the right hand. So you start at 0.
So it does not matter.
It doesn't matter. I mean, the final result doesn't matter because you start at the left end and right end. If you break to infinite pieces, you still exactly area under the curve.
Why is the cosine 1? Why is the cosine of pi included in it? Why isn't it just x?
Because there's pi in because it's cosine 2 pi over n, cosine 4 pi over n. See it?
But wait, isn't that just x though? Isn't that whole thing
Because
just
x would just be 2 over n and 4 over n, but you need the pi in there to make it 2 pi over n and 4 pi over n.
That's poppy.
If there wasn't the pi in it, it would just be cosine 2 over n instead of cosine 2 pi over n.
Well, I know why the pi would exist in the answer. I'm so
Okay, yes, but you need
the validity of the pi being the answer itself. And the integral of 0 to 2, the integral of 0 to 2 of x is 2, buddy. So you're pretty good. So I don't know what the hell you were bobbing.
Because like, it would have been if it was a horizontal line, but it's a diagonal line.
right after this?
I don't know.
Can we scroll back down to 14?
Like, no, you don't say can, you say scroll down and
Very rarely you're gonna see this type of question, but I just want to cover, make sure all the angles covered.
Can you go over 15?
Oh yeah, you probably should go for 15. It's a little scary question. Okay, then you can do it on the board first.
Okay.
Oh, I was so close, man. How did I get?
I'm here.
15 is right there.
Do you want? Can I do a 15 on the board?
Sure. Yep.
So the 15 also, the I value is
15 is start at 1.
It just starts at 0 instead of starting at 1. So from there, you can see that.
Well, for B, it's gonna start at 0.
I'm not talking about part A, I'm talking about part B.
Oh, I didn't even see there was a part B, to be honest.
Dude, then sit your down. Sit your ass down, bro.
She started with the function.
I don't.
the B part. For proving the B part.
0 to 2.
So I solve for the integrals of both and I compare that they both are same.
You don't need to, they didn't ask you to evaluate anything. That's not
Yeah,
a
but
goal.
we have
But
to prove
also,
that it is same.
also, hold on a second, let me make sure. Oh, you just proved that they are the
Yeah,
same.
yeah.
Okay, that's fine. That's fine.
So that's what we have to do.
Well, no, I mean, math is, there's no one set way to do things, and they
Yeah.
just want you to establish a proof. But basically, if you have a graph shift right, or shift, I mean, a graph shift left, and your boundary also shift the same thing, you're gonna give it the same result. Okay, does that make sense?
Okay.
Yeah. So, a lot of time that you think about graph, if you shift the whole graph to the left, and you have the boundary also shift exactly 1 unit to the left for the upper bound and lower bound, you are gonna get the same answer. Does that make sense? So it doesn't matter if you can change that boundary that have shift, and also this point, the second one is to shift the whole graph over, or the first one shift the boundary. It's just gonna equivalent. They are equal to each other. Okay. Anyway, so we're gonna talk about go back to talk about one more thing. One more thing I missed throughout the time. I'm not gonna cover Newton method because not on the AP exam. But I want to go back to talk about why is tangent line approximation important.
Oh, we never did that, and I'm still confused by them.
Yeah, so that's what we're going to talk about.
God bless your soul, Mr. EA. Thank you. I hated these, but like, I just need help, man. You do.
Mentally, yeah.
I mean, that's an understatement.
Logan, you can criticize me when you do your homework for an entire week, all week.
That's
Okay.
fair. That's fair. I'll give you that.
All right, so why do we use tangent line approximation? Because something this one is gonna build into when we're doing the calc 2, when we're doing like a BC calc, that we can create an equation using polynomial look like a sine functions. Okay, so but you have to basically start by understanding why tangent line approximation, that's very, very important. So let's just say if I have f of x equal to 1 plus sine of x, right? What is the derivative?
Wait, where are you doing this on the board?
Oh, sorry, my bad.
Yeah, I was a little.
You're okay, Mr. Yeah, we forgive you.
There we go. So if we start with 1 plus sine of x at this point 0, 1, and then we say it's f prime of x equal to cosine of x. And then how do we're going to plug in 0, right? If we plug in 0, what am I going to get? It's a 1. So it'd be y minus 1 equal to 1 times x. So y equal to x plus 1. So this is the tangent line, right? And this is the original function. Now let's compare into the graph. So tangent line approximation are fairly accurate if in a very, very close range. So this is the requirement. If something is really close, it's actually fairly accurate. So we're going to show you on decimals. On decimal, we're going to do 1 plus sine of x. So we're going to show you 1 plus sine of x. So 1 plus sine of x. And we're going to come back and talk about this. And y equal to x plus 1. Y equal to x plus 1. So if you see here, right, they are almost, if it's something that's relative small, they are almost exactly identical to each other. I mean, if you plug in, just say if you plug in, you build a table on each, and we're going to show you if you build a table on each. Just says not like -2, but at 0 to like maybe say 0.1. So let's say 0.1. And even let's say 0.01. And as opposed of here, 0.1 and 0.01. You're going to see that they are really, really close to each other. If you see that at 0.01, they are like 1,000th to each other. So it's a fairly good approximation. Now, back then, this is important. Mathematician, this is important because back then they don't have a calculator. They don't have a calculator that can spit up 1.099. So what they do, they use approximation to figure out what the value is. Does that make sense?
Yeah.
So this is very, very important for back then. But also because of this, you can use this idea to something like power series, right? You say something like, well, how do I make a sine graph look like using polynomial? So use everything in terms of polynomial to represent exactly like a sine graph. And this is a building block to that. Even though we say we don't need to learn this, we have decimals now. But the foundation of that lead to something like power series and Taylor series to help you building different things. So a lot of time, tangent line approximation. So we're going to also talk about what is the difference between two. In terms of this one, it's going to be a small changes of y. That's going to give you a 0.01. Here it's going to be 0.01. It's the same, almost identical to each other. Almost the same, not identical. Sorry. Let me get it back. So let me go back to talk about the other one. So I want to say, compare what's the difference between those two. So sometimes a textbook will ask you to say compare the delta y and dy. And you got to look at the small details. But we're going to go into approximate a value. Let's just say, hey, let's try to approximate something like this. That's a square root of 16.5. And use the idea of differential to calculate the approximate value of square root of 16.5. So what we're going to do is we're going to assume a function. Y equal to square root of x. What's the derivative here?
Y equals
So we're gonna take it something called differential. Then that's gonna be dy, and then it's gonna be 1 over 2 square root x dx.
You understand, Bobby?
I'm understanding right now.
Are we okay here?
Yeah.
Now, let's talk about what is dx. Why do we always write dx? Well, dx is useful when I use substitutions. But what is dx? Dx is small changing of x, which is back into the things that we're talking about. For example, 3 over n. That is the dx. Because that's just basically width divided by how many rectangle you're going to have. So what happened is, how do I approximate this value? And then you think about it. You say, okay, well, we know dy is very, very close to the small changes that you're going to have. Okay, dy is going to be very, very close to the small change that you're going to have. So then you say, okay, well, we know that is equal to 1 over 2, right? Which value we're going to use? We're going to use square root of 16. But what's the dx here? From 16 to 16.5, what is dx?
0.5.
So it's a half, right? So then you see, so we're going to approximate this and compare to what calculate approximation. So it's going to be 1 over 2 times 4 times 1/2. So it'll be 1 over what? 16?
Yeah.
So we already know square root of 16 is 4. So you are basically adding this to the dy. So 4 plus 1 over 16, that's equal to, I don't know, 65 over 16. Okay, so let's see how accurate this comparison is.
Wait, is that 65 over 60, is that what square root of 16.5 equals, or what the derivative would equal?
No, this is a differential. So what I did is I take a differential. It's like derivative, but
But we just got an answer of 65 over 16. What does that number represent?
that represents an approximation of square root 16.5.
Okay, so not the derivative, just the square root.
No. So that's the approximation because we have the y, right? Y plus dy. That's the goal. If you approximate this, you can get actually pretty close to that approximation. So let's just change it to square root of 16. So let's go to decimals and that says what is square root of 16.5? Right? It's 4.62. And what is 65 over 16, I think? 0.625. So it's pretty close, pretty accurate for 200 years ago's approximation. Now later on, you're also going to learn something. If we have time to learn about Newton's method, which is we don't. Newton's method is using the tangent line approximation and to finding the zeros. So in this case, that was a very good approximation. Now dx can be negative though. What if I ask you what is a 15.8? Then what's my dx?
0.2. You do the same thing, it'd just be negative.
Negative 0.2. Right. So this is a very good approximation for anyone to do. And this is a very important for them. So I want you to try to calculate the cube root of 26.7. So what is cube root of 26.7 and the process of actual approximations?
And this is like the basic approximations shit, right?
Yeah.
Wow. I think we learned it a different way last year.
Oh,
Because the AP exam formats it in a different way.
they format in a different way, but it's pretty close. You're still using y minus y1 equal to x minus x1. If you really think about it, is what? Y minus y1 times m times x minus x1, right? And we know the y is equal to 16 is equal to 1 over 16 times x minus, which is in this case is delta x. So what would it be to delta x? Delta x is what? X will be 16.5 minus 16. So 16.5 minus 16. So y equal to 16 plus 1 over 16 times half. Wait, so 1 over 16 plus half? Oh no, sorry, it's 1 over 8 times half. This one's 1 over 8. Because if you think about dy dx here, is equal to 1 over 2 times 4, so it's equal to 1 over 8. So same approximation, just using tangent line approximation. So I show you the tangent line approximation right here. It's the same answer regarding to 65 or 16. It's the same idea to approximate something.
I don't even know what I would do that. Wait, don't we have wouldn't this be
Nicole, you have a amazing power, can block out this too.
Yeah.
You mostly you have like earphone like.
I'm learning talent.
Multiply.
Is it 269 over 9?
I have no idea. I didn't do it.
I mean, the math looks correct.
It's 1 over 27 times 10.
So, unless you multiply
I
the
this,
wrong.
So it'd be y equal to the x to the 1/3, right? And if I do differential if I do derivative, just say if I do derivative, right? dy dx. So that's equal to 1/3 x to the negative 2/3, right?
Yes.
And then, so if I use a tangent line approximation, I can use the same way. So y minus 27 is equal to what? What is m in this case? I'm going to plug in 27 in there. So it'll be 1/3 of 27 to the negative 2/3 times the delta x. What is the delta x? Which is 27 minus 26.7, right?
Yeah.
And that's going to be exactly same per approximation. So this is 1/3 times 1/9. So it'll be 1/27, I think.
Yeah.
Times negative 0.3, because this part is the delta x, right?
Yeah.
And then y minus 27, so y equal to 27 plus 1/27 times negative 1/10. I have no idea what is that.
1/10, 3/10.
3/10, I'm a dumbass.
Yeah, I couldn't do that, that's too
I
much
just
work.
used the calculator. So
Oh, that's a
it's
good
not
idea.
270.
Negative 1/90, I think.
Yes.
So whatever that is, I don't know.
But could you show us how you did that in the first format?
The first format is the same thing. Is you look at it, this is the same exact thing. Y plus y1, dy plus dy, pretty much. Using tangent line approximation, you're gonna get exactly the same thing. Which one?
The last line, wouldn't it be the cube root of 27?
Negative 190.
Yeah, that's what I thought. I said 3 minus 1/90.
Oh yeah, this is a cube root of 27. You're right. How much time I have?
1 minute.
Less than a minute.
Okay, that's fine. Now I'm done with this section. So, okay, so math competition. Let me know if you're interested. Now, what I'm gonna do is I'm gonna spend next 2 days to talk about differential equation. Those of you guys take Calc 1 last year, you know what's a differential equation, which is separation of variable. You guys remember that?
Maybe. I have to see it.
Okay, we're gonna spend 2 days on the separation of variable, and we just knock out. We will be able to finish Calc 1 in the first semester, and then we're gonna start with Calc 2 when we come back to next year.
What is the combination we do, Gabby?
I didn't know that.
Yeah, I can imagine.
Bye.
I remember going to OSS.
OSS, don't mention that.
I know,
I hate
it's like
OSS.
this trauma.
OSS is the worst.
Wait, were you in the OSS, Gabby? Were you in the OSS?
Oh
I
yeah.
went there for math competitions in elementary.
Oh no.
Oh.
The math competitions were fine. It was actually going.
I specific build up my old math team, just build up to beat OSS. We come very close. We come in like 20 points away, but it take me 3 years to do it though.
Because I love math.
It's okay.
No, they always host it and then they win it and it's so annoying.
What? That's why band competitions can't have the host compete. Adios.
Bye.
Students, 1 minute remaining until class.
leave your message for...
Hi, sorry, I was focused on something. My fault. Is today's stuff making sense?
Yeah, no, it makes a lot of sense. Once you understand like the addition part, like it's pretty easy.
Yeah,
I don't know what the homework's gonna look like, but
it's something like that.
yeah, okay.
Let me post your homework now. It's not hard.
Oh, thank you. Oh yeah, so for like the midterm, I know it's gonna be like multiple choice, but like how many questions is it gonna be for?
100 points?
100?
Yeah, but it's gonna be curve. 70% A.
Okay.
So yeah, it just go back and look at the test, look at the things. The format is gonna be a little bit different, so you're gonna have to learn how to adopt.
Are we gonna get like some practice questions beforehand, or
No.
no?
If you understand the stuff I give out, it should be very intuitive.
Okay.
It's the way my teaching philosophy is just throw kids in the fire, and if they know how to jump it outside, then they're doing good. If it doesn't, I put the water on them, and then I say, okay, well, let's get back and do it again.
A little violent, but okay.
Yeah, I mean, I guess you can say that. It's not about violence. It's just the way to think about things. You have to. This is how like a higher tier education is like if you go to MIT, right? Let's just say you go to MIT. I know I talked to the student a lot. She told me, says, well, yeah, my professor just kind of gave me a homework.
Mm-hmm.
And like, we have no freaking clue how to do anything. But we just have to figure out there. And the tests, we don't know what to prepare. But we just have to prepare everything. Because now, first of all, I'm paying for the course.
Mm-hmm.
The problem is high school people don't pay. If you make people pay, they'll be more serious about school. Right? Actually, that'd be a good idea. They force people to pay. They will try to do much better at school. Because there's no incentive for them to work hard, because for them to say, okay, you're gonna get a good job in the future if you do well in education, Is that entirely true? Maybe not, but more likely you'll become more chance to become successful. It's not like for certain, for sure. You can get education, you can become homeless, very depend on how you do it later on in life. But the essence of, you know, have people try to reach the level is much better than just set the bar low and just, oh yeah, I can reach it. So a lot of math class you go to is really easy A. Like your physics class probably is easy A. There's no bar setting. The bar's right here.
Yeah, unless you take the test home.
Yeah, the bar's like right here. And how much the maximum thing you're gonna learn? But if you set a bar there and you try to reach for it, it didn't matter. Anybody from that class, anybody from this class, going to that class easily exceeding expectations. So you should try to, you know, have student reach for the things instead of just hand it to them every time. And the best thing about this class is you guys have group chat. You guys spend a lot of time talking about different things in there, and so that's what college is like. In college, like in UCF, the group chat is like our group chat, except there's like 1,000 kids in the group chat instead of like, you know, 60, 70 kids. But we operate exactly like college. We just, do we know what's on the test? No. Do we know how many questions on the test? No. Do we know what to expect? No. You just have to expect to prepare for everything. And then, you know, that's that way. I mean, that's life. You just. But anyway.
This last test was fairly easy if you like knew like the procedure, like how to do everything.
Yeah, it wasn't. Well, first of all, you guys go through related rate already, so your mental status is already kind of used to it. So that the first time, the related rate was a killer. Like first time you seen related rate question, you was like, oh my god, what is this, and how do I even start? But now you got some foundation to knowing how to read the questions, knowing how to do things. Yeah, it should be getting a lot easier. Should be. But